Hello everybody, welcome back. Today we're looking at the final section of chapter 4. It's 4.4, solving problems using obtuse triangles. So when solving problems that involve trigonometry, always draw and label the diagram with the right information. That is key here. So first of all, you want to draw a right angle triangle, right? Or what we call a right triangle. So here's an example of a right triangle, and you want to use your primary trig ratios, right? This is where you're using sine, cos, and tan. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tangent is opposite over adjacent. So if you have a right triangle, you're using these three primary trig ratios. That's the easiest method to solving that. Next, we have an acute triangle. This is what we did in chapter 3. So this is grade 10. We use this a lot in grade 10 as right triangle. Acute is what we learned in chapter 3 in the previous chapter. And next we have an acute triangle, and here we can use the sine or cos law, right? So this one we have all angles are less than 90. You can use the sine or cos law, right? Again, there's some scenarios for that, right? Use the sine law when we have the scenarios such as sine angle, right? Angle, side angle. Again, remember the sine laws when you have those, you have to have at least an angle with one of the known sides, and then one of the other angles or sides. And we remember those scenarios. And remember cosine law, sine angle side, or side for cosine law. Okay? And then our last scenario is when we have an obtuse triangle. So we clearly see that we have one angle. Angle C here is obviously greater than 90 degrees. So we have one angle greater than 90 degrees. And again, use the sine or cos law, but just be careful. You could end up with that ambiguous case, like we had earlier on in the previous video on 4.3. Okay, so let's look at example 1. Example 1 says a surveyor in a helicopter would like to know the width of Garibaldi Lake in BC. When the helicopter is hovering at 1,610 meters above the forest, the surveyor observes that the angle of depression to 2 points on the opposite shores of the lake measure 45 and 82 degrees. What is the width of Garibaldi Lake? All right. So, first thing you want to do is you want to sketch a diagram. I think the most important thing is here to give yourself a sketch of the diagram of the situation. This is where we usually have students get into some complications, because creating a diagram can become a little bit difficult. And I would completely agree with that. All right? So I'm going to start off with the diagram of the situation as the way I see it. So I have the helicopter. This is directly 1,610 meters above. And then we have the angle of depression, 45 degree angle here, and then this 82 is the larger angle here. So this line here would give you the 82, obviously. And then it's at the front and the end of the lake. Okay? So that's going to create two right triangles, if you think about it. So the first right triangle it's going to create is, so from my diagram, I'll have one triangle. It's a right triangle. Remember, using the Z pattern, we have the horizontal here. We created the angle of depression with. So there's the Z pattern, or the alternate interior angles. So that makes this angle in here 45 degrees. So if we go directly vertical with the ground, we have the 1,610 meters with a 45 degree angle here. So that would actually, I mean, you could calculate that, but that obviously is going to be an isosceles triangle, and the distance from here to here will be also 1610. But you could calculate that using the tangent, right? But some people would recognize that that would also be 1610. The second triangle you would have would be a much smaller triangle. See, this triangle, if you look closely, it went directly below. So the helicopter wasn't quite directly above the starting point of the lake. So there was this angle of 82, again using the Z pattern or the alternate interior angles. This angle in here is large angle 82, And again, you have a primary trig ratio for the right triangle that you could solve and obtain the b value here that they have listed. So in the first part here, you didn't have to calculate A, but if you want to, I'm going to show you how and why it is actually 1,610 as well. The horizontal distance here, we call it A. So remember from grade 10 and earlier on, tan theta is equal to opposite over adjacent. So theta is 45 degrees. You can just put 45 in. I know there's a degree symbol there. The opposite side is 1610. The adjacent side is just A. So we solve for A. A is equal to 1610 divided by the tangent of 45. Tangent 45. And the reason we get 1610 is because tan of 45 is equal to 1. Tan of 45 ends up giving you 1. So A is equal to 1610. That's what we predicted earlier. And like I said, the reason that is because it's a 45-degree angle. This is an isosceles right triangle, right? So the opposite and the adjacent sides have to be equal. Okay? And then we do the same thing with the second triangle we've created. Like we've done these problems actually in grade 10. But when you're identified a problem now, you can determine what you need to do. That's the whole idea here, is figure out, do I need to use the primary trig ratios? Do I need to use law of sines, law of cosines? That's the whole idea behind this. Okay? Oh, that was B. I apologize. I left A in there. We're looking for side B now. A smaller triangle. So we do the same thing, only this time the angle is 82 degrees. And when we calculate that, we get B equal to, so on my calculator goes 1610 divided by the sine of 82, or sorry, tan of 82. So used to doing sine tan of 82. And I get 226 decimal 3. We'll go decimal 3. So to answer the question, what's the width of the lake? The width of the lake is equal to A minus B, right? Pretty straightforward. Which is equal to 1610 minus 226 decimal 3. So width of the lake is equal to, we subtract those two numbers and we get 1383 decimal 7. And we can round that. It didn't say to round, so you can leave it like that. I like to round. When it's the numbers that large, I like to round it to the nearest meter. And put my unit in, right? And we can answer with a final statement. The width of the lake is 1,384 meters. And if it asked for kilometers, which sometimes it could, then you would just divide that by 1,000 and you get 1.4 kilometers. Okay? So remember, when you're tackling these questions, you don't necessarily have to go directly to the law of sines or cosines. You could have used the law of sines here. The law of sines will work with a right triangle because you've known this angle was 45, right? So you would have had a pair and another unknown angle. You could use the 90, but there's no sense because we need this angle to get A. But it would end up being the same, right? Because you're taking tan 45 divided by tan 45, which is 1. it would work out to be the same. Okay? Let's go back to that same question we had with Martina and Carl before. That can be solved this way. And remember, hint, there's two different possibilities. So that's pretty interesting. So we could work that through that question again, like we did in the previous video. So I won't do that again, but it's done. If you look at 4.3, the answer's there for this particular example. Okay? And that's it for this. Maybe I'll get the information from that previous. Just 1 second, I'll grab that information. So there are the two scenarios from Martina and Carl again. The two situations. We could have some people in the class drawing it this way. We'd have some people in the class drawing it the other way. And both scenarios would work. So here are some word problems for you to try on page 194, number 2, 3, 4, 6, 9, 11, and 13. So that's it for chapter 4, folks. I'm hoping you're enjoying the videos, and next we're moving on to statistics in chapter 5. Thanks for watching, and we'll talk again soon.